So I'm about to tell you today about the 5 years or so which I have now been co-maintaining Ledger SMB, the ERP and accounting project, which is entirely written in Perl, but it's a web application which is written, well, still half of it is left in the original 1999 CGI style, mixing complex up to extremely complexly coded business logic interleaved with HTML responses. And, well, the rewriting process is still continuing, but it kept breaking both existing and rewritten workflows. And about a year ago, around this time of year, I completely had it. Drastic measures were required, and that's where I started working on what is today the Weasel project, and which is the result of factoring out most of the testing logic out of our project, which I have written since then. A little bit about myself. I'm a self-employed solutions architect and business analyst in the financial services workspace, and I'm also one of the co-founders of FSC Limited, who are cloud hosting the small and medium business ERP system called Ledger SMB. Ledger SMB originates from 1998. It's originally written as and known as SQL Ledger, but in 2006 the current project maintainers decided to fork from SQL Ledger, as it is open source, but it's not developed in the open, and Ledger SMB is. So we have our project hosted at GitHub, and that's also where we have landed our Weasel code. So about a year ago, I had to solve a few problems in our project, and these are the ones. The code which kept breaking is non-modular in the sense that you can't actually even call it from the outside and run any unit tests on it or anything. The code is highly complex due to the fact that one script requires another and then overrides functions by defining functions by the same name twice or even thrice. And then you have to figure out which one was last required, which also happens at runtime during function evaluation. Now, you understand now how easy it is to break this software. And as a matter of fact, this fixing one bug often led to breaking another workflow, or even the same workflow in other circumstances. And since manual testing was the only option at the time, many breakages went undetected too long and ended up in production systems for customers who, well, had to have emergency fixes. So basically, no happy developer. Originally, as in years back, as even before I joined the project, which is roughly 6 years ago, there was already a web testing framework in place, so-called version 1, but it was a framework where handcrafted requests would be sent to an HTTP server, which would be, and the response would be compared with a handcrafted response. Well, if you intend to fix more than one bug in a fortnight, then that's not the way to do it. So it's extremely labor intensive, it's very boring to do, and as a result, it wasn't maintained. Basically, we were looking for a different solution. In recent years, BDD, or behavior-driven design, was one of this is a thing that has come up with agile development, and some 2 years ago I was confronted with that way of writing, with a way of writing tests that goes with it. It's a great way to make end users understand what we are trying to test for, as the testing scenarios most of the time read like documentation, at least in the way that we in our project try to write the tests. And the great thing about that is that the web testing that I had been writing before that in browser testing was a series of driver commands which would execute clicks and stuff like that, which is still very labor intensive, not as much as handcrafting requests, but still, and took a lot of time to get right. So basically with the BDD approach, we were able to compose tests of a series of high-level instructions which are easily verified and easily composed into new tests as well. Even more so, by making the step to BDD, we hope to expand our contributor scope into technically knowledgeable end users who are maybe not able to write code for us, but who are able to write either the tests or pseudo tests, which we can very easily translate into real tests. And added to that, one of our co-developers had great experience with the BDD testing for websites that he builds professionally. So at least it was worth a try. And for those of you who are not familiar with BDD testing, basically the test, there are a few keywords to be had. One test consists of a scenario with a short description of what the test is testing. Then there's a keyword which says given, which has a certain assumption in the test. Then there's an action to be executed in the application, and maybe a second action to be executed, and then there's an expectation to match. And just this first instruction, given something, in the Perl code, it's 4 lines. It's now high level. I know exactly what I'm doing, yet I don't have to write the Perl code. I don't have to write a series of instructions. So basically it's building a higher level language on top of Perl. A full example of a feature file for those of you who have never seen one. A feature file is a file where an entire feature is being tested in a number of scenarios, or a number of edge cases may be tested. There's a general description at the top. Then there's, which doesn't do anything in the sense that it's just information for anybody reading the file below. Then there's a background keyword, which lists one or more steps which have to be executed on every scenario. There are scenarios, which I explained about just a second ago, and then we have the given, when, and then keywords. Basically, that's all you need to know in order to be able to write one, except for that you need to know, of course, the sentences, which are the test execution instructions. Now, there are a number of BDD, well-known BDD execution, BDD test tools. The main one being written in Ruby called Cucumber, which is the de facto standard. And there's another one in Behat, our developer who introduced us to the idea of starting to use BDD. Use Behat himself because he's doing Drupal development, and that's all written in PHP. But for us that wouldn't work because we wanted to integrate and we want to use the application libraries that we did have written to manage application and access application state. So we went looking for a Perl solution. Fortunately, there was one. Actually, there are several, but the one we found was test BDD Cucumber, which has a command line application which is called Pherkin, which refers to Gherkin, the language that Cucumber uses. So the reasons for us to go with test BDD Cucumber was that it was under active development, It has a standalone command line interface, which allows execution of parts, so subgroups of tests, which when developing new tests, we're looking to develop hundreds of new tests. So we're obviously not interested in running the entire suite all the time during this development process, so we want access to just running subgroups. It has a standalone, and it has colored feedback of the parameters it parsed, the commands it parsed, and which it didn't, which failed nicely. It has contextual failure reporting, so it reports every step that it executed, and then if one fails, that's where it ends. It has integration with the test builder infrastructure, so we can run them as part of our prove infrastructure. And the author of the module, Peter Sargent, had expressed the desire to stay really close to the Cucumber language, Pherkin, and be compatible. So for us, that was another argument, because we wanted to be able to switch solutions later on if we had to. Now, all that being said, we at least had something to go on. So we made an initial trial implementation. And what happens is that we need to set up a basic directory structure in our T directory, and Pherkin will execute the tests for us, which are in one specific directory. It will load all the step files, so this the mapping from the high-level instructions to the flow code. It will load them if they're in a step definitions directory, and we split up nicely the code in general purpose and specific purpose little bits. So then how does that look? We started out really small, so it was 2 tests for the login and 2 tests for setup, which in the application basically are are the general user login and the admin login interfaces. So 4 tests, which were basically doing nothing other than just logging in. Now, how does a step file, what does a step file look like? There's some general pro header, of course, then there's a use instruction to set up the environment for further definition of the setting up the right environment for the definition of the individual steps. And this instruction also imports the nice what's it called? The keywords. It introduces the keywords sorry? The DSL, yes. It introduces the DSL for the given, the when, the then. Sorry about that. So basically, you have a keyword as the same as in the file, in the feature file. Then you have a regular expression which is being matched, and then a function which will execute the Perl instructions matching the, in this case, it's a setup instruction. So it makes available, it parses the definition of the username and the password, and what happens in this one is that there's a stash set up, so the entire scenario will have available some memory storage, and that will be cleared on the next scenario. We set up a username and a password in that storage, so the next step can make use of any values which have been earlier provided. As is actually a function, but in the context that doesn't really make much difference. So our tests were successful in the sense that we had not been able to increase our code coverage testing up to more than 11% so far. And with just these 4 tests, which were logging in and logging out, we were able to increase it to 15%. So that's still not enough, but it's a huge increase. So in that sense, the test succeeded, and we wanted to proceed. And since we wanted to scale up to hundreds of tests, we decided that the next step would not be a proof of concept that we could do it, but which problems do we run into if we try to scale this up. So we had a few growing pains. Well, we wanted to use the Pherkin command line interface, as I said before, because it allows us to run a subset of tests. But so far, we have been depending on the feature file and the ordering of the tests in the feature file to do certain test setup for us, and then subsequently run all the tests in the file. But that doesn't work anymore. Okay, so there were a lot of items that we ran into, but we still needed to be able to do the use Pherkin. Pherkin does nothing but step-level scope execution of developer-provided code. At this point in time, this is by January. But as a developer of tests, we need this output because the test builder output is providing the description of the failing test, but if you build the blocks correctly, you're using them all over the place, so the same description is going to happen all over your test code, which means that you have to figure out by the count of the number of the tests failing, which one it was. That's not practical. So we wanted to do a pre and post test run hook. We wanted to do a pre and post feature hook, a pre and post scenario hook, and we wanted to do a pre and post step hook in order to be able to catch the step success result as well. I mean, Pherkin reports it, but as a developer, you want to hook into that kind of stuff and do something with it. The partial execution happens by tagging either entire features or scenarios, and you can then select all features with a certain tag to be run or to be excluded. So maybe you want to run all work in progress features or all work in progress scenarios, but not the one which are tagged run me not. That's all provided through the command line interface. The test builder interface is integration is a bit more simple. There you have to either code that yourself or it will simply run them all. But for continuous integration, we didn't have a problem with that, but for test development, we did. So we approached Peter Sargent to help out and donate the concept of Pherkin extensions, which we nicely took from Behat. They documented it pretty well how they did it. All we had to do is do the same, but hook that up into Pherkin. And he was glad to accept. So now we have, by February, a test, pre-test run, post-test run, pre-feature, post-feature, and now we can hook our own code into the execution cycle of tests by creating an extension. And there's a role definition in Pherkin, which, when applied to a Moose class, makes your own Moose class into an extension with a number of default implementations for methods, and it will do nothing, but it will just be accepted as one. An extension also can provide its own step files, which means that if you have an extension which does nothing but provides step files, you can have composed libraries of step files, which we could, for example, happily distribute through CPath. The extensions have access to the feature and scenario stash, so they have a means for communicating with either the self-provided steps or other steps who will want to use services provided by the extensions. And in order to be able to fire up an extension, we had to have a configuration mechanism, and the configuration mechanism has been the already existing, by the way, Pherkin YAML file, and we have an example here. We can imagine, and we took this from Behat as well. You can have different testing scenarios. So there's a profile name at the top. You can select any profile from the configuration file from the command line, and then it will load all the settings below. So it sets include directories, and you can declare extensions, and the values provided here are provided as startup values to the new constructor for the declared module. So basically what we are looking at here is the extension, one of the extensions that we developed, Pherkin extension Weasel, and it has a number of sessions and other connection parameters in order to set up a web testing environment. Basically, Pherkin extension Weasel is the glue between what is Weasel, which in turn is a concept taken from Behat as well. They have a Mink extension and a Mink library. A Mink is the library which is in the extension is the access to the browser. So here we have an extension providing access to the browser access. And it generates screenshots on certain events, which it monitors if you configure it to do so. Now these screenshots are all numbered at the moment, so I kind of thought that it would be nice to have a transcript of all browser interactions, visible, renderable in HTML so that you can quickly inspect, and also have the step names and the step result in a table-like format in HTML so that you can find the screenshots and everything belonging together quickly, which can now be a little bit more difficult due to the fact that they're all numbered. Okay, so what does that do to the step file? Basically, I now have each extension can announce itself in the stash. So I have an object sitting in the stash for which I can call services. The one listed here will simply browse to the URL provided, prepended with the base URL that we had in the configuration just a minute ago. Okay, so what is Weasel? Well, it was inspired by Mink, but it's different from Mink in the sense that it is not a browser access tool, because we have Selenium Remote for that, and Mink is not either, but Mink has a wrapper we have a wrapper for Selenium Remote. Mink has six wrappers, Sahi, others. But what we want to improve on with Mink is that Mink has basically has a number of facilitating access patterns. Like, I want to find a button which has the text OK, but if on your page any other element lists OK, then it will find that and try to click on that. So maybe you want to override the pattern which is being used to find your element. Now, in Weasel, this was an explicit design choice. We want to have the developer, the user of the library. We want the user of the library to be in charge. You want, as a developer, you know what you need. As the developer, you know what you want, and if we hard-code it, it works today, but it will not work tomorrow. So we had problems so far with only the 4 tests that we developed. We had hard-coded XPath expressions throughout. We found those in Mink. We just copied them and used them, but then they started to proliferate, and everywhere we had these hard-coded XPath expressions. We had other repeated locators, and basically what was pretty annoying is that Selenium Remote has a one-size-fits-all return value type. It's the web element. And even if the web element isn't selectable in the sense that it's not logical to call isSelected on it, it always offers the method. That feels unclean. So, preferably, we want you to be able to use your own driver technology, Sahi, whatever. We want you to define your own behaviors for the elements that you created in the web application, and we want you to be able to define how to find those. So basically, it's flexibility to proxying the behaviors that we have in the web browser to Perl. How do we do that? Well, we have a few building blocks. We have, same as the Selenium, we have an element, we have a driver, and we have a session. But due to the fact that we have the don't hard code requirement, we also have a concept which we call FindExpanders. So basically these are mnemonics passed into find element or find all, and they will expand into an XPath expression later on. And that XPath expression will be used to find all elements. And we want to be able to attach behaviors to the elements returned from the find or the DOM browsing functions. We do not want to lump everything into the main namespace. We specifically want to attach behaviors to elements because the elements in the browser also have these specific behaviors, the ones you implemented as the developers of the web application. So the first one is the FindExpanders, which is defining a label, for an XPath expression. Well, I think the sheet says it all. What's interesting about the concept, what we do here, is that you can register your own, but also you can register as many as you want, and we will calculate the composed XPath expression for you and find the first one, or we will find all of them for you. And since we use Dojo Toolkit as the base framework for development for our own application, we already did some work for some of you, because we have a few widgets from the Dojo Toolkit already transformed into FindExpanders. Adding your own is really simple. You need a function definition which returns an XPath expression, always a relative one because it's going to be applied in a relative context. And what we saw just on the previous sheet, all the arguments after the mnemonic, the label, will be passed into the function so that a dynamic expression can be composed as well as a static one can be returned if need be. Some of the ones that come built in are being dynamically composed because you can provide an ID, a label, a text, or whatever, and we want to filter only on the elements which have been provided. And then we register them by a label into a category, and then as the function, I see I edited this morning, but I forgot to remove the expander on top here and there. So basically, it should have been without the expander, or the statement should have been with the expander. Why the categories? Well, maybe you have multiple sessions. You have one application space where you have multiple sessions. Some you want to apply some expanders, and in others you want to have other expanders. So later on, you can choose which sets of expanders you want to apply to which session. So summarizing the concept of the FindExpander, we have now centralized XPath expressions. We have the possibility to expand on one single label expander, it being expanded to something that you want, add on to them, and they can be invoked or called by name in order to do an ad hoc expansion as applicable. There's only one drawback, because they are being composed into one single large applicable XPath. We can only support the XPath locator scheme for now. Yes? That will be an option in the future, yes. Yes, the question is, can we use other tools to translate CSS locators into XPath locators and lump them into the final result? Yes, in the end we can, but for now we're at this stage, yes. Okay, the other is the concept of widgets, which is the idea that widgets in the web application are being proxied into widgets in the Perl side, and they have these. This is the place where we distinguish the various elements that are in the browser, and the different, which have different behaviors. So here is also where we attach the specific behaviors. It kind of started to look like normal object-oriented programming again. And that's, so every element which has specific behaviors gets its own widget implementation, or a role which can be unified into one. Then we also wanted to have kind of an API for elements in the standard HTML set. So like select is a classic example of something which seems simple, and then Dojo Toolkit comes along and a select is completely written into a DOM tree which is not even linear anymore. So, but yet still, you actually don't want to change all your test code when you're changing from one JavaScript framework to another. So what we did I'll get back to what we did for the Dojo Select as an example of how we can now abstract widget behavior in it. And again, you want the widget, which is the element which is being returned to you by a find or by whatever DOM traveling function, you want it to exhibit immediately the properties that you want it to have. In other words, you don't want to assume that it's a certain class. It has these properties and it is the class. So we have a dynamic mapping of elements retrieved from the DOM to element classes which are being returned to the test developer. And there's a dilemma that I was toying with all the time. That is, where does my page object style page objects begin and where does a DOM element end? In other words, if I am writing specific code which is to abstract my page, which is what the purpose of a page object is, where does something stop being just a return value from my DOM, and where does it start to become something special in terms of something that provides a service to my application end user? Well, I'll get back to that in a bit. And then we're now to the select element that I was referring to, and how we address that. Basically what we did for the select element is that we added an accessor in order to be able to retrieve the options. And in case of a normal select, that is just returning the children. And in case of a Dojo toolkit select widget, it means returning a new root somewhere at the end of the DOM tree document. So, but the test developer doesn't need to know, because he will simply get a list of options now. And that's where this starts to work versus where Selenium Remote starts to break down, because as a developer with Selenium Remote, you need to know, because you need to go and jump through your DOM tree, and here we encapsulated that entirely in the object which is being returned. So basically this is closing the gap between the fact that if we write static behaviors like the isSelected method or how you retrieve your options, which breaks down when you are developing your JavaScript enhanced web pages, your web applications, which are changing behaviors and even go so far as to Dojo, which replaces a select element with a bunch of tables and divs, which cannot be matched with anything anymore. Not at least in the original namespace. And so that's where we are closing the gap with how widgets, that's the solution the widgets provide. Now, in order to be able to map at runtime the classes that you implement to the DOM elements that you provide, we have a registry of module names, class names, and a matching algorithm. And upon every page access, which can return an element, that mapping is evaluated and the right one is selected and instantiated. So this is what the Dojo toolkit does when you instantiate, when you give it a select element. It has a div which has a number of options, which has a hidden input, which has a value, and then the actual options are all the way down at the bottom of the DOM tree. So using the FindExpander for select with the Dojo toolkit support loaded into Weasel, you will still get this as your response without the need to do anything. Originally we developed Weasel against plain HTML, and when I switched to looking at Dojo, all that I had to do was developing the correct expanders, and I didn't need to change anything in the tests. So the returned class, at first it was Weasel Widgets HTML select, and now it's Weasel Widgets Dojo select, just to demonstrate the power. How do we then map an element to a class? Well, we have a matching algorithm which uses configurable criteria. In other words, there are a number of fixed items, but you can configure the input. If we have an element's ID match, well, then it must be the same. There's the tag name, of course, which is a criterion. We have the number of CSS classes, matching, and the matching number of elements attributes, because, well, if you can add, here too, you can add and add and add more elements, of course, to the DOM tree. We will need to find the most relevant one. And we do that by counting the number of matching criteria, and we'll take the most specific one. And then the most specific one wins. If there's a tie, we'll take the last one added to the list, which is just an estimate of what you probably meant, but we'll still warn. Adding your own is really simple. This is just a code. This is all the code that there is actually in the HTML button. So we wanted to provide just a button response. It extends an input which has nearly the same definition, but all it does is register itself with the package name in the HTML subset, and the tag name is a button. And to be honest, I removed all the variants of input which can be considered a button. So this is where you can start, and then you can add your own methods and role mix-ins in order to add actual behaviors. But it's not required. This is a start. So at a certain point in time, I think it was April or something like that, I came back to the question, when do I make something a page object, because I had started developing a lot of page objects, and when do I have a DOM tree element? Well, in fact, the two aren't so different if you have the ability to return something that provides services directly from your DOM query API. Actually, they're the same thing, just providing different services. One is maybe a high-level encapsulating element which which can return other elements and other values, and the other may be, or at least were initially, more simple, like inputs or other elements. So what we started to do in the Ledger SMB project is we started to make all our page objects into registered widgets, with making sure they are identifiable either by class name or by page ID. And we now directly query the page, and we'll just assume that the response is of the type that we want to have, or we can just assert that through ISA. So basically the conclusion was every element provides a service, and every element thereby is a page object. And they now have been unified through this dynamic mapping. Now, tying that all together, we have in the Ledger SMB project achieved that we can use both Pherkin and Test Builder integration, one for development, the other for continuous integration. We use Weasel with FindExpanders widgets from standard, with a number of Dojo wizard widgets that we additionally developed. We have our own set of page objects which self-register as soon as the tests start, because they are specific to our application. We have a custom extension which allows our tests to query the application state at the database level, at the server level, during testing. We have the Weasel plugin to access the in-browser state. We have tests of code which we perceived previously being impossible to test. And we define our tests using BDD terminology, which gives us the high-level constructs that we wanted. And we increased code coverage from 15 to 25% in 2 more months. And it's still increasing. So, how do we envision to proceed? Well, for the Weasel project, there's no website at this point, but I want to create a website making that into kind of a library of information for Perl in-browser testing. One of the things that we had to fight with was the fact that in-browser testing has been extensively documented, except for Perl. We want to abstract out and work with other projects to create a larger standard library to include in Weasel of standard test steps for in-browser testing. We want to extend the functionality of Weasel and the Dojo widgets and the HTML widgets from works for a Ledger SMB project to works for most of us. And I hope to build a community around the Weasel project as well as we have now around the Ledger SMB project. So, to get you started, what resources do we have? Well, we have a Matrix chat channel, which is a new kind of get-together in chat. We have a Google group. We have a GitHub org where we store all of our work. We have the website to come, and we have a lot of example code in the Ledger SMB repository so far. So, that's basically the scope of a year's worth of development. And is there anything that you want to add? Question, comment? Yes? Well, I can repeat the question. That's no problem.
So, the mnemonic was the whole BDD thing in general.
Yes.
So when we use that production, how much work is it really to build new glue code to add new features to the app?
Well, the question is it how difficult is it to build new glue code when you want to build new features to the app? Well, to be honest, what we do is there are a lot of low-level interactions which we can just, like the clicks and other stuff that we used before, we can build that first, and then we can initially test, and once the number of tests increases, we start to abstract those out into single steps. So there's not a need to immediately take it all the way and create for every new functionality new steps. There's a mix to be had. So I think the effort depends on how much effort you want to put into it.
Can we talk a bit more?
Sure, no problem.
What I'm thinking is when you have the product people, when they define a feature, they can also just directly write down, given there's this part of the website, when I click this, that should happen, kind of thing.
Yes.
If I want them to write that, and then I write glue code. At some point, they probably wrote so much different, they're called backgrounds, right?
Yes.
So much different backgrounds with so much different rules that the product people and not developers will basically lose the overview, and they will get lost in it. Is there kind of like a built-in way to all of that to generate something that they can use to look up what they have to do, because otherwise they will probably fuck up the
Okay, so the question was, will there be, will the number of rules not grow so fast that the people who write the tests, business people, will lose overview and simply lose it and, so that the test won't work anymore? Well, at the moment there's no such thing for Pherkin, although it is planned, and I hope to talk to Peter Sargent this conference about next steps for Pherkin. But tools like that have been implemented indeed for example, Cucumber, that there's syntax aiding tools like rules, listing all rules which partially match the sentence that you started. So it's definitely possible, and it's one of the things that we want to add to Pherkin, but it's not there yet. You're welcome. Other questions? Yes?
If Dojo gives you such a messed up version of the DOM, why are you using Dojo, or was it already being used by...
Okay. So the question is, if Dojo messes up your DOM so much, why use it? Well, because it gives a what we're developing is not just a web page, but it's a full business application. And we're basically abusing the browser as a full business application interface. And it's really hard, it's nearly impossible to have a good framework which doesn't do something weird to your DOM. And but the advantage of having the, for example, select widget the way that Dojo does it is that the select widget that Dojo renders the same on almost every browser. And try to get that in normal HTML. It's really hard. Yes?
Do you have lessons learned when it comes to dealing with really large BDD tests? Like how to use text or
Yeah, so we have what we are doing now is that we're defining so you have the features, but we're grouping the features into application functional areas, and we're only loading the step definitions applicable to that area of the application. So that helps us not tread on other business users using nearly the same language to describe a completely different thing. But other than that, at the moment we're still into scaling up. So we're up to 300 tests now, but that's a little bit skewed because there's a lot of repetition in the tests. Yeah, so I hope that answers your question a little bit. Yes?
Well, I expect that most tests start with log the user in.
Well,
or are you tweaking and creating sections on the fly by accessing database and stuff like that?
okay, so the question is, does every test start with log the user in? And the answer to that is no. Some tests, and there's basically that would mean that every test would start with create an application instance, create my user, log my user in. No, that's not how we did it. We said, okay, given an existing base setup application, and then it generates all that. It accesses the database directly, and it sets up a logged in user in a session, in a browser session, and then you start coding the rest of the test. So, well, not the base. Actually, the response was we have a better code base than his. But the base can't be worse than what we have. But we're trying to move away from that. One from the right.
How about this program? The road, maybe the road, maybe code service.
Yes, we have, I think, I have to look it up. We have 125,000 lines of code at the moment. So, and that's Perl, no, that's the total code base size. Perl code is 50K, and we have roughly 50K PLSQL code. Okay, next question. Yeah. Yeah. No, we don't have that at the moment. We're looking at expanding the code coverage testing to both the JavaScript part, which is as we're progressing development into a service-oriented structure, to have JavaScript coverage testing, and to we're thinking how to do it in SQL, PLSQL, yes. But no, we don't have it at the moment. So we're happy to increase even the base that there is. Yes. How we resolve the problem of not using a light database? Or live database. Well, what we have done is that we have a number of tests, and these tests generate some base transactional data, and we just store those as a base test set of relatively normal interactions into the application, and we load that as a quick load to start halfway. Yeah. Then there was another question here. Yes?
If your application, like you have a feature you're testing, and if a user action causes new stuff to be loaded into the web page or web app, making on the fly new page objects, or?
Yes.
Okay.
Yes, so the question is, are we generating new page objects on the fly when we are querying, we're changing the state? Yes, every response is a new page object, and the actual, so this is why it's called, why I call it proxying. The actual state is in the web page, and we're just querying that. More questions? Okay. No more questions? Good. Then thank you for your attention.